Lagrange error bound looks pretty intimidating. It's actually not as bad as it looks once you actually work out a couple of problems with it there. This is like the formula for the Lagrange error bound. You maximize the n plus first derivative, and this is like your normal Taylor polynomial stuff where C is your center of your Taylor polynomial, n is the degree, and then they typically will give us the next value right there. Don't worry so much about that all the different letters and stuff with that notation. Let's just do an example. I really had to dig deep to find this one problem here. We'll do a couple on this video, and then if we see a couple more, then we could practice that, right? But here they give us a fourth derivative, and they tell us third degree Taylor polynomial. So when I see third degree Taylor polynomial, that means that's my n. Now my n is equal to 3. And then it says about x equals 0. So that's my c value is going to be equal to 0. And then really the only other problem, the number in the problem is like that 1. So it's not really that clear. Like I said, I had to dig really deep. This is a really old problem. But the only other number in that problem is going to be like x equals 1 right there. So what we'll do, when we apply the Lagrange error bound, we're going to maximize that fourth derivative. So I got to do the maximum of that e to the sine of x. And then you're going to do x minus c to the n plus 1. So your x is equal to 1, your c is equal to 0, and then the n is equal to 3. So then this is going to be to the fourth power. And then it says n plus 1 factorial. So that's 3 plus 1, which is going to be 4 factorial. So this part is easy on the bottom. The 4 factorial, that's just going to be 4 times 3 times 2 times 1, which will give us 24. You're just going to get a 1 for this part of it. And so really, it just boils down to figure out what the maximum of that fourth derivative is going to be in between 0 and 1. Now, this was on the calculator part of the test. And if you graph that function in between 0 and 1, it does something like this, where the maximum is going to occur when the x equals 1. So we're going to like plug in the 1 for the x to figure out that y value right there. So the maximum, like if it went downhill, the maximum would occur at x equals 0, and then I could plug in the 0 for the x. But the maximum of that particular graph occurs when x equals 1. So if you just plug the 1 in for the x right there, so you're just going to do e to the sine of 1, and then this just calculator work there, that's going to give you 0.0967, 0.0967, which is 0.097. So you'll get B for your answer right there. This is not something that's used a lot. They tell us when to use it. I've only seen it used like 2 or 3 times, like ever on the AP test there. If they give you an alternating series whose terms decrease in absolute value to 0. So if the terms themselves keep getting smaller and it keeps alternating sign, they're meaning for us to find that next term in that sequence and use that other technique that's called the alternating series bound, use that other technique to find the error. But if we do the Lagrange error bound, that's this guy right here. So I already explained how to do this on the video. This is the 2004 Taylor polynomial problem for number 6. I explained how to do this on that video, but I just want to kind of have that all together in the one thing here. So on this particular problem, notice that it tells us to use a Lagrange error bound. And it's talking about the difference between the estimate, like P of 1/10 is if you take the 1/10 and plug it into your Taylor polynomial. Alpha 1/10 is you plug it into the actual function. And so the difference between those, that's the error that your answer is going to be off by right there. And then notice, just as I look at that Taylor polynomial, those terms don't keep getting smaller and smaller. It's not like a 1/2, 1/4, 1/8, 1/16, 1/32, where those terms keep getting smaller. And I guess it doesn't go plus minus to be like a true alternating series. So that's kind of another reason why we're not going to use just that next term to find the error like we would do on some other problems there. But the biggest thing is it gives us the Lagrange error bound right there. So what we'll do, we'll need to maximum, and this gives us a third degree Taylor polynomial. So this time my n is 3, so we want to maximize the fourth derivative. And up here in part A, we already had the third derivative, so I had to take the fourth derivative, and I figure out what was the maximum of that. So you know your sine graph, you're going to go up to 625, down to negative 625 for that amplitude right there. It's not shifted up or down at all, so that would be your amplitude. And then so the maximum of that is going to be 625. And then when you're using this formula, you're going to go x minus c. The x is, that's just like f of x, p of x. The x is that 1/10 right there. That's how I know I'm using that. And the c is the center, which is about 0. So I'm going to go 1/10 minus 0 to the fourth, because n is equal to 3, so 3 plus 1 will give me the 4, and I have 3 plus 1 factorial on the bottom right there. So you just maximize that next derivative, and then you're plugging in that x, x minus t to the n plus 1 over n plus 1 factorial there. So just knowing the formula a little bit, and then when you have to work it out, this one was a little annoying that I had to do all this without the calculator. My goal is, at some of the recent tests, they make the stuff a little bit easier without the calculator, but I just simply rewrote the 625 as 5 to the fourth. I rewrote this as 1/10 to the fourth, so the 10 to the fourth drops to the bottom. And then that was like 2 times 5 to the fourth, so that was 2 to the fourth times 5 to the fourth. The 5 to the fourth cancel out. And I still had to do 16 times 24. I did like old school multiplication here to get this 1 over 384 right there. So most of the time when we see an error in the AP test, it's going to be just finding that next term in the sequence, and then that'll be our answer right there. But we'll use this if it says Lagrange error bound, and we'll just get some more practice with that eventually. But even, I tell my students all the time, it's not something that hardly pops up. Like even all that trouble right there, that letter C was worth 1 point only. So it's not hopefully the end of the world if we're going to focus on everything else first. Make sure you master all the parametric stuff, the polar stuff, the Taylor polynomial stuff, the power series stuff, everything else. But we'll just, what I ask you, just learn how to do a couple of these problems, and if you see something that looks similar to that, we'll at least get those right. If you see a thing that looks a little bit crazy, we're going to say screw it. We're going to do the best we can on all the other problems right there, and have fun with the rest of the test there.